Okay, so Assalamualaikum. So hari ni we're going to do the revision for chapter 2. You can refer the tutorial at the end of this chapter 2. Okay, I will begin with question number 3. Okay, so let read the question first. Okay, so the AC circuit shown in figure 1A is connected to an AC supply. The equation for the voltage supply is 150 cos 2500 T plus 30 degree volt, and the corresponding circuit parameters are R1 100 ohm, okay, R2 250 ohm, and then we have 10 millihenry of inductor and 250 microfarad of capacitor. Okay, calculate the following: parameter voltage, phase shift, maximum current in the circuit, and then the voltage across capacitor and the voltage across the inductor. Right, so firstly let's look at the circuit. Okay, so we have voltage source, okay, resistor R1, C capacitor, 250 ohm for R2, and then we have inductor. Okay, so to answer the question number 1, okay, the RMS voltage. So firstly we have to look at the voltage source given. Okay, so let's recall a bit what is the parameter for voltage source. Okay, so we have Vs 150 cos 500 T plus 30. Okay, so remember this is Vm. So Vm. Okay, so this is function. Okay, so the function is cos, and then we have 250, which is our omega. Okay, omega T, and then this is theta. Okay, so the first question, okay, to determine Vrms. Okay, remember Vrms equals to Vm divided by square root of 2, and then the angle of theta. Okay, so for this case, okay, Vrms equals to, our Vm is 150, so divided by square root of 2. Okay, so the answer is 106, the angle of 30 degree volt. Okay, so this is the answer for Vrms. And then the next question is phase shift. Okay, phase shift for so remember, okay, phase shift you have to refer at the function. If the function is cos, okay, the angle here theta minus 0. Okay, the answer it should be 30 degree minus 0 equals to 30 degree. Okay, if the function is sine, so you have to minus this angle by negative 90. For sine, okay, you have to minus, okay, theta minus 90 degree. Okay, so this is phase shift. Okay. Right, so next one is Imax. Okay, maximum current in the circuit. Okay, so the maximum current is IE. Okay, the total current for the circuit. Okay, so okay, we will use formula Imax equals to Vs divided by Z total. So firstly you have to determine Z total. So before we can determine Z total, you have to convert all parameters in ohm. Okay, especially the impedance. Okay, so we have, okay, so yang ni dah in term of ohm, so tak perlu convert, ini pun in ohm. So what we have to convert is C capacitor, which is infrared, you have to convert in term of ohm reactance, and then VL in Henry, so you have to convert in ohm. Okay, so still remember the formula for determine inductance reactance. So yang ni we call reactance inductance. Okay, so the formula is J omega L. So J, so we know that omega is 2500. Okay, multiply by 2500, and then multiply by L is 10 millihenry. So the answer should be J 25 ohm. Okay, so J 25 ohm, and then for XC, okay, 1 over J omega C. So 1 over J omega is 2500, C is 250 microfarad. So when you enter the calculator, you have to insert the unit, milli and micro. So if you calculate, the answer is negative J 1.6 ohm. So why it become negative J? Because of 1 over J, you will get negative 1. Negative 1 J. So and then you should remember that XL is positive and then XC must be in negative capacitor. Refer back to impedance triangle. So to determine Z total, let's assume so actually this circuit is parallel, it's just a parallel circuit. So we have one junction here and then another junction over here. So let's assume this one is Z1, which is consists of 100 ohm and then XC, and then for Z2 is 250 ohm plus with JXL. So this is Z1, and then this is Z2. So the connection for Z1 is and Z2 is parallel. So Z1 is in parallel with Z2. So that assume Z1 equals to 100 ohm plus dengan JXC. So 100 plus, if you can see JXC is negative 1.6. So this is Z1, and then for Z2 250 plus JXL is J25. And then to determine Z total, Z1 is parallel with Z2, based on this circuit. So Z1 is 100 minus 1.6, parallel with 250 plus J25. So this one you just insert in the circuit, in the calculator. So 100 ohm. So make sure your function is complex. 250 100, use bracket, so 100 minus 1.6 I, because of this is capacitor, and then negative 1 plus with 250 plus 25 I, so this is XL, and then negative 1. So press the answer and then press another negative 1. So the answer is, so this is in term of imaginary number 71.62, which is our resistor, plus G 1.21 ohm. So in this chapter, better you convert in term of magnitude and angle. So shift, and then you plus shift plus, and then press equivalent, sama dengan, so 71.63 angle of shift sama dengan 0.969 ohm. So this is the answer for Z total. So for I max, so VS divided by Z total. So remember which VS we going to use is VS, the original VS, 150 angle of 30, because we not change the angle because of the function is cos. So VS use that, use the VM in term of VM. So this is VM, VM angle of theta. Not use VRMS. VRMS just use for power calculation. So this one is 150 angle of 30 degree divided by 71.63 angle of 0.969. So the answer for IE is 2.094 angle of 29.03 ampere. So in term of magnitude and angle, right? So next one, the voltage across capacitor and the voltage across inductor. Okay, so when we look at this circuit, okay, you can use, okay, because of this circuit is just in parallel, so you can use VDR, voltage divider rules. Okay, so okay, firstly, okay, draw the basic circuit for, okay, VDR, voltage divider rules. So actually okay, you just only have to draw this one. Okay, so this is the basic circuit. We have VS, okay, and then Z ataupun R1 and R2. Okay, so for this case, R1 and R2 is, R1 is equals to 100 ohm, okay, R2 is J, negative J 1.6, negative J 1.6 ohm. Okay, so what we want to find is this one, VC2. Okay, VC V capacitor that across capacitor. This is JXC. Okay, JXC equal to negative J 1.6. Okay, similar with this junction. Okay, this the same circuit. That's why I draw this one. So you want to determine the voltage across capacitor, across inductor. So for VL, okay, between R2 and JXL. Okay, for VC, this is VL, and then this is VC. Okay, for VC is between R1 and JXC. Okay, because of this is just parallel circuit. Okay, so remember VDR, voltage divider rules. Okay, if I can recall back, okay, for example, we use R1 and R2 here. Okay, so to determine voltage across VR1, okay, R1 must be in top. Okay, R1 over R1 plus R2 multiplied by VS. Okay, the voltage across these two capacitor, two resistor. Okay, for this case, okay, we want to determine voltage across VC. So for sure, JXC must be in top. Okay, and then plus with R1, and then plus with JXC. Okay, multiplied by VS. Okay, so the answer for VC. Okay, so this one you have to include all the J, which is negative J 1.6 over R1 is 100 ohm minus negative J 1.6 multiplied by the voltage. So voltage you have to insert the magnitude and angle, 150 angle of 30 degree. Okay, so the answer should be 2.4 angle of negative 59 volt. Okay, so same goes for this one. So JXL is J25 over, okay, R2 is 150 plus J25 multiplied by VS 150 angle of 30 degree. So you will get 14.925 angle of 114.3 volt. Right. Okay, so we move on the next question, tutorial number 4. Okay, so you can read the question, okay, and then you can extract the information. So firstly, given 20, okay, our voltage 20 sin 1000t plus 70. Okay, so remember 20 is our Vm, this is our function, this is our omega, this is our theta. Okay, so the first question, the frequency in hertz. Okay, remember our omega is 1000. So the relationship between omega and frequency is, in hertz, is omega equals to 2 pi f. Omega actually is also frequency, but in unit of radian per second. So you have to convert omega in term of hertz. Okay, so the relationship is omega equals to 2 pi f. So to determine frequency, okay, omega divided by 2f. Right. Okay, so omega divided by omega divided by 2 pi. So 159.155 hertz. So this is 1000. Okay, divided by 2 pi. Okay, so next is, okay, the voltage supply in phasor form. So remember, this is in term of phasor form. Okay, magnitude and angle. So because of the function is sine, so you have to convert the theta, which is our phase shift. Okay, you have to minus by 90. So the original theta is 70 minus by 90 is negative 20. So our Vs is magnitude of 20 from the equation, and then the angle is negative 20. Right, so that one is the voltage supply in phasor form, and then the phase angle of the voltage, this one lah, which is our phase shift. Phase shift 70 minus with 90. So next one is the total current in the circuit, by using the formula of I total Vs divided by Z total. So firstly you have to convert all parameter in ohm. So we have capacitor, one capacitor here, C1, C2, and then also inductor. So all these impedance you have to convert in ohm. Remember XC1 is 1 over J omega C1, so our omega is 1000. So you will get negative J33.33, negative J33.33, and then for XC2, negative J20 ohm. This is ohm, this is ohm, and then XL J omega L equals to J5 ohm. So secondly, let's look at the circuit first. So we have this inductor series with this capacitor 1, and then we have R series with capacitor 2. So between this junction and this junction is in parallel. So let's assume this is Z1, this is Z2. So Z1 is parallel with Z2. After this is parallel, so it will be series with 10 ohm. So our Z total, firstly Z1 JXL, J5, plus JXC1. JXC1 is negative J33.33, and then Z2 is 10 ohm plus with JC2 negative J20. Z1 and Z2, and then Z total is Z1 parallel with Z2 plus 10 ohm. So as usual, you input in the calculator. So for example, for J5, 5i plus with negative 33.33i, and then parallel with in bracket 10 minus 20i. So and then 3.29, and then you have to plus with 10. So convert in terms of magnitude and angle. Sorry. So the answer is 30.11. With the angle of shift negative 56.76 ohm. So this is Z total, and then to determine I total, remember this is Vm with the angle of negative 20. This is after we minus 90 degree because of our function is in sine, so we have to convert in terms of cos. So 20 divided by 20, the angle of negative 20 divided by Z total, so you will get I total is 0.66 for angle of 36.76 ampere. So next one, we want to determine the phasor voltage of VC1 and VC2, which is the voltage across C1 and then the voltage across C2. If you look at the next question, the next question asks for dissipated power R1 and R2. So R1, we assume this is R1, and then this is R2. So it is convenience to solve this question number 5 by using CDR, so that we can use the current to determine PR2, power across R2 10 ohm. So I will solve this question by using CDR. Okay, so to determine CDR, remember you have to draw the the circuit, the standard circuit for CDR. So we have I total, I1, I2, this is Z1, this is Z2. Okay, so firstly we want to determine VC1. So VC1, which is VC1 equals to I1 multiplied by JXC1. Okay, so the I1 is flow through Z1, so this one is this why lah, this is Z1 and then this is Z2. Okay, Z1 and Z2 is combination between based on previous question. Okay, so I1 Z2, remember to determine I1 you have to put the adjacent impedance on top, which is Z2. Okay, and then you will get I1 is equals to 0.609 angle of 51.24. Okay, and then for I2 you just simply I total minus I1, you can get I2. Or you can use also CDR. This is CDR. So you want to determine I2, so the adjacent impedance is Z1. So Z1 is in top, so divide by Z1 plus Z2 multiply by I total, and then I2 you will get 0.1963 angle of negative 27.5. So you can multiply I1 is this one multiply by JXC1. So JXC1 is, okay, you can refer back what is JXC1, and then same goes for VC2, which is I2 multiplied by JXC2. Okay, so this is I2, this is I1. Okay, and then you will get the answer. Okay, the answer for VC1 is 20.32 negative 38.76, and then this is 3.387 angle of negative 117.5. Okay, good. Okay, and then for power, PR1 and PR2. Okay, so this is PR1 across R1, and then this is PR2 across R2. Okay, so PR1, okay, the current that flow through R1 is I total. So remember the formula for P equals to I squared R. Okay, for this case, okay, that the current flow R1 is I total squared. Okay, so okay, saya pun tak kira what is PR1. Okay, but make sure you include the angle for I total, which is 0.664. Okay, sorry, just magnitude, because of R dia tak ada angle. So 0.664 squared multiplied by R1, which is 10, and then for I2, okay, I2 0.1692 squared multiplied by R2 is also 10. Okay, and then you can get the answer lah for PR1 and PR2. Right, thank you.